Now we're going to have our roundtable panel discussion that will be moderated by the Honorable Magí Galindo. Magí is the R&D Unit Director of Leitat in Terrassa, a master's in rapid prototyping and manufacturing for SME. During the last 24 years, he's been professionally devoted to advanced manufacturing and 3DP technologies and their application. At present, he is the Technical and Scientific Director of IM, the 3D Hub, and Leitat Advanced Manufacturing, Additive Manufacturing 3DP R&D Unit Director. Magí, I will let you take it over from here. I'll go get you, we have one microphone here. Do we have another one down there?
I think
probably best if I was to get you 2 microphones. Okay? I'll get you another microphone. Go ahead, take over, Magí.
Thank you very much, and thank you for your attendance. Thank you for your presentations. All of them have been really interesting for me. And in my experience in additive manufacturing years and years ago, really it's impressive the advanced what we are seeing in the applications. In terms of conducting this roundtable, I would like to invite you to make questions to all our speakers. If you are thinking in your potential and ask for potential questions, I will fulfill the wide moments with my own questions. Okay? I would like to ask directly in the same order you have presented. Okay? Because if I take some notes or your presentation, then it will be easier to move the microphone between us. And then, Susanne, mobility goes additive. Is it real? Or is something like a hope because of we need to change the way we are managing the companies? We need to change training. We need to change the way we are designing in order to take the most advantage. We need to overcome more challenge we have in additive manufacturing technologies that doesn't answer all our needs. We need to research in much more materials, and mobility is really a very requiring sector. Do you think mobility goes additive? Real? For sure? How far are we from a real application of additive manufacturing in mobility?
I mean, first of all, we are a network. Whenever we appear, we represent 100 and more companies, all looking into additive manufacturing. So I cannot speak for every one of them, but surely all of them are very, very interested in seeing how 3D printing will develop over the next couple of years and 20 years, decades, whatever. I personally think that there will have to be a big change in mindset, but I think this has to come with behavioral change. Because we are so used to what we usually do, and as we are humans, this is sort of our, that's our weak side. So we tend to repeat and repeat. This is what we're used to. And now we have to change, and we have to change thinking, basically. So there will be a change, but I think digitalization will help us to adopt. And what we have done, I explained it briefly during my presentation. Change management is a big issue for a lot of companies, and it's a big change for an organization, but it's doable, and there's means that can help you, just like a book. That's just only one means of things, but it can help.
It can help. Thank you very much. Is any question from you? No? Then to Arcelor Mittal, okay, you have said, and I think literal words. The supply of spare parts in our company is in itself a new business. But at the end, you said, I need to try with more applications, more needs. Okay, then how you manage, how you balance, or how you select which parts of your maintenance needs make sense to be solved by additive manufacturing technologies? Which is your criteria at the moment to select this part makes sense or this part not? Okay, how you are facing that? Thank you.
It's a really good question. So we were working on that almost 1 year, defining exactly what type of parts could be sensitive to additive manufacturing initially. And we have changed a little bit the focus, because initially we were thinking on high-value parts. Let's say these parts that takes too much time to be supplied by anyone. We have even parts that takes almost 6 months. One of the parts that I was showing in the presentation, just for giving you a reference, the cost is around 20,000 euros, and we can print it by 12. So that's something that has sense, that we can reduce the price, but at the same time, we reduce the supply time, because we are talking about 6 months, right now 2 weeks. So the things initially were really focused on that area, and we were all the time pointing to really high-value parts. Currently, what we are doing, and is focused with, or link with the presentation that José López was mentioning, is we are trying to identify new technologies, and some of them, they are printing in metal in a lower price than polymers. So you can imagine that the numbers can go down, really, really down, let me say. And in that case, many of the parts can be substituted. So many casting parts, many machine parts can be substituted. And this is a new way of being focused on how to replace the parts. Okay. That's how we make it.
By using these technologies to help in your spare parts, how do you manage the problem of certifying these parts and be sure that these parts will perform in the same way that the original one? How do you face that, please?
Well, mainly we were using same standards as... initially, we tried to assume what should be the standard we need to apply, or what should be the protocol to verify that. And we were trying to identify organizations that help us in the same way that Tup was mentioning before, to identify the way to make the protocols. And we get in contact with one interesting partner, that is EWI, that is a Center of Excellence for ASTM standardization for additive manufacturing. And at that moment, we start to discuss with them, and they tell us, okay, guys, at the moment, just use what you have. So if you are trying to replace a founding part, just apply what is applied in founding and make exactly the same trials. So we start to do it in that way, and we take, of course, the risk, because finally we are testing the parts in our own installations. And up to now, let me say, the performance was really good, because just for giving you an idea, but in a drill bit that you can imagine, drill bit is nothing that is easy to analyze. We reduced the drilling time in a blast furnace, 1,400 degrees C, that is working at that temperature. We reduced the drilling time from 6 minutes to 20 seconds. And the part that has been broken, it was the VAR, that is a standard part. That breaks, but the drill bit was performing quite well, was going out in Inconel, no problem at all. And in the case of the thin pump, it was something funny, because we were facing exactly the same problems as Timo was mentioning about cavitation and all these things. And when you play with hot thing at 400 degrees C, the things change a little bit. And all the experience that we have is that the foundry part was living with us almost 6 months, and every 6 months we need to replace. And right now the additive one is working more than 1 year, and is performing really well. And we were applying exactly the same criteria as the foundry parts. That's exactly the way.
Thank you very much. Okay, and then Victor, first of all, okay, I am explaining just in Spanish. Sois muy valientes, okay? You are very brave, because of you have faced alone...
Or very crazy.
Yeah, I don't know. This is my question. Okay, And lots of companies want to explore additive manufacturing and 3D printing in order to know if it makes sense to use them and take advantage of their capabilities. You did so, but you did alone without any kind of help, facing a need without no knowledge. After this experience, you have success. What or which one would be your advice? ¿Cuál sería vuestro consejo at new companies that wants to start a way similar you started, you did at the time? Okay, how a company can face the adoption of additive manufacturing in a more soft way, not as wild as you did?
100 years ago, vessels, ship, was manufactured with nuts, and before in wooden material. After that, welding. Why not additive manufacturing now and in polymeric? Why not?
If you want, if you need to,
you know the
yes,
shipbuilding is a very industry very traditional. Then it's necessary change ours. It's necessary we change our engineering, and after that we go to convince to other persons.
Okay, then the advice for other companies could be, please train your staff in additive manufacturing first to face technologies, because you know, all the companies represented here, I think, are big companies, really big companies. And it's not as easy to do the way as they did when we are a small or medium company, because of the risk of investment in technology without a deep knowledge of that, okay? And I know lots of companies that have failed in this trade to start with additive manufacturing. For that reason is my question. Which would be your advice? And you said, please train your people and convince them to change the mind. Thank you very much. Then 3D hubs. No, sorry. We are going to move to Damen. Damen is quite a similar kind of company, different, I think. And you said you did more or less the same. You started with something small to convince them or convince somebody to use additive manufacturing. Then you try to make a part by additive. You enter in the register of, you said, that records, mundial records, worldwide records, okay? But you did a part you could make just by foundry, by printing a sand mold and casting them, okay? Easier, shorter in time, cheaper, and you decide to make a kind of part. Why? Just only for understand these technologies, just only to learn about their capabilities, because in terms of business, it makes no sense, in my opinion. Can you explain why did you start with this part? Because then the message then was, and now we are trying to use these technologies to make things better, take more advantage of their possibilities or potentialities. But why did you start with this part and not with another, with this kind of, from the very beginning, how I can take advantage of additive manufacturing to do parts in a different way? Okay?
Yeah, thank you. Well, I can definitely confirm that printing a propeller, if anyone wants to try to print a lot of propellers, don't, because I think it's 5 times more expensive, if not more, than a normal one. But if you just print a mold in whatever material and then cast it, you still do the same as you did before. And you don't really learn that much, of course. Okay. So the reason for us was really to learn what can we do with this technology. And also to show, well, the rest of the company, but also the rest of the other companies, that it is a feasible method to use and that it is worthwhile to investigate more. And in that case, well, you can print any straight part of the ship hull or whatever. But it was also because the propeller looks cool, of course. Everyone knows what you're talking about when you say a ship propeller. Mm-hmm. And it was really... that was mainly the reason, because we wanted to show something that we can use to prove the world that we can use additive manufacturing in the shipping world and certify it, because you can print any shape, but to use it on board you still need to do a lot of tests, do a tensile test to show that the material is strong enough, that the design is okay. So the one that I showed was not even the first one. We first did a prototype to show we can do it, and then a second one to show we can apply what we learned with the first one to really show that it's strong enough and it will stand testing and operations.
Okay, thank you very much, Agata. Then, if there's some more questions, I can repeat more. You are facing additive manufacturing from the service world, okay? Services to additive manufacturing. We are now exploring the additive manufacturing just beyond the prototyping, just beyond the help in the development of products, okay? But is it real that companies are moving from prototyping to tools or to final parts, or the business of a service bureau like yours is still remaining mainly in helping in development, in prototyping?
Yeah, that's a very good question. I think definitely, especially for smaller companies, it's definitely real. Like we've seen it as well as 3D hubs. Companies start using 3D printing and other technologies, the service industry, for prototyping, and they kind of start getting a little bit more confident, and then they start testing us out with kind of low volume runs and then production runs as well. Yeah, it's definitely real. Of course, at the end of the day, I think in some cases 3D printing hasn't done it so well just because it hasn't been chosen like for the right applications. So you can't expect 3D printing to, I don't know, replace CNC machining for high-value aerospace brackets or whatever. But you can expect 3D printing to help in the R&D industry in the aerospace sector. And you can't expect 3D printing to help maybe small, medium companies to start their low production runs. So yeah, I think it's definitely getting real. We're getting there, especially now with the developments of more materials, of quality standards like what you spoke about, Christoph, as well, is definitely helping making that real. So yeah, I think so, yeah.
Okay. And as a service bureau and facing the industrial needs, this forum is called From Needs to Solutions. What kind of needs you are seeing that have no any kind of solutions yet in additive manufacturing? When somebody approaches you asking for, I need this kind of solution, or I have this need, have you any solution for me? What kind of challenges you think are not solved yet at the moment?
Yeah, I think, again, I'm going to kind of repeat my point as from before, but I think when it comes to kind of more high-end industries, the quality issue is still a little bit there. Okay. Just because, I mean, you can prove that the material properties are exactly the same, but as you know, in the aerospace industry especially, to have any type of change, yeah, it takes a while. Even just like with composite materials, if you want to change the layout just a little bit, then it goes years and years of testing before it actually goes into components. So yeah, I think that's kind of an issue that I was actually very happy to hear. A presentation is of quality standardization in 3D printing itself. I think that's a challenge that we're facing, and a very real challenge, and it definitely needs to be solved now. Yeah.
Okay, thank you. Yes, just a question.
I do have an addition to where does additive manufacturing still fail? It's not failing to the very 100% extent, but whenever it comes, it has been mentioned also, flame retardant products, any sort of very highly safety relevant issues, then we still lack the right materials. And so is it also with elastomers. So there is applications and there is certain developments being made, but we are not yet there. And this is an area where we still have to push.
Okay.
Yes.
Okay, thank you. And next, Aintzane. Thank you very much for your presentation also. Then your presentation has finished inviting companies to be part of this incubator. My question is, which criteria are you using to assess and select new projects to be hosted in the incubator?
So, as I told you before, this initiative is being promoted by Leitat and by Consorcio de la Zona Franca. As you know, Magí works for Leitat, so this question wasn't arranged at all. I mean, we didn't talk before this this round table. I mean, actually, we do have a specific criteria, such as having to do with 3D printing, but mostly what we are looking for is for initiatives that seduce us. We are looking for people willing to do many, many things with 3D printing. They don't really necessarily need to know about this technology, because that's what we are here for. For instance, Magí Galindo, we are here to help you adopt this technology. So basically, you don't need to be an expert. You just need to have a great idea. You just need to have a great compromise with the initiative, and we will find the space for you.
Okay.
Yep.
Are you asking, another one, just short one. Are you asking for equity to the entrepreneurs?
No, we are not. We are not asking for any kind of equity. So if you want to be incubated here, the only thing that we are asking you is for a commitment of 6 months minimum, maximum 1 year. Afterwards, we can talk again. And in this period of time, we are not asking for any equity in return. We just want many, many initiatives to grow in this incubator.
Thank you very much.
Thank you.
It's more or less time, but I need to ask one more question to Christian. Christian, you have explained that you are working hard in helping companies in the way they can certify what they are producing, and mainly to the OEMs, okay? Then my question is, how companies can, in the future, certify part by part they produced in additive manufacturing? Are you thinking in a kind of digital and virtual certification?
Yeah, right. I mentioned it in the end of my presentation. As I said, I brought 2 parts with me. There's our orthopedics, and they have, by production already, a QR code or GS1 code in it, where you can see when the part was produced, how the process parameters were during production. So, for example, build room temperature,
laser power,
for example, O2 concentration,
position of the point,
right, everything. How was the scanning strategy and so on. So, based on that, we as TÜV Süd have the possibility to already predict the quality of the part. So, with this, we can at least minimize the step of really mechanical testing, for example, and therefore, make the qualification and certification process a lot faster.
Okay, thank you very much. It's our time, but it's not the time of finish. Okay, we have 10 minutes more. If it's some question from the audience, please. And I invite you also, speakers, please, if you have cross questions between us, please don't hesitate to ask for. Okay.
Hello. We can see all the potential of the 3D printing technology for the industry.
A bit closer, please.
Hi. So we can see all the potential of the 3D technology for the industry, but when do you think this technology is gonna move to the domestic area? So we are seeing every day that the stores, they have right now 3D printers, the prices are dropping quite a lot, but this is a kind of market that it's only for tech or let's say geeks users. So do you think this market is gonna explode soon?
Is there anyone of you? Susanne, please. Okay.
I think what I understood is you're looking for a consumer market. Is that okay? I think, I mean, right now, how do we do 3D printing? We obviously scan the old conventionally manufactured part. We check it on its characteristics, criteria, and so forth. We create a file, a digital file, and then we put it into a machine, post-process it, and when it comes out, then hopefully we have the right part. I think the future will be, and this is where the chances are for consumer market, that as soon as we find a technology that can basically scan, so you place your item, whatever you have in your household, any sort of, I don't know, whether you have an old lamp that somehow got broke and you want to reproduce it because you emotionally linked to it, then once you're there, to being able to scan it, push the button, and then you take it off, copy it, then we will all have it in our households. Before, it will be a too difficult process for consumers to go through. So the likelihood is rather small, I think. Anyone else?
So one more question, please, for Christian. In terms of how far we are from having machines reliable, repeatable, and in your opinion, how far we are from having this kind of technology much more reliable than now? No, for Christian.
Okay.
No, just to Christian. Christoph, sorry. Wow.
No problem, no problem.
Christoph.
Well, actually, it's a good question because, like I said in the presentation, right now a customer come to us, for example, from aerospace and also within automotive. In this session, it was also mentioned that they need a lot of qualification effort to print a part in the way it should be, like in an industrial way. For example, automotive, it took 1 year, and aerospace, it took 6 months. So, especially for reproducibility, I think our way, by testing specific standardized specimens and testing them for different mechanical features, is the best way to ensure reproducibility among machines of one machine type. When we will see it, hard to answer, to be honest.
Okay, then if a company wants to be certified to produce a kind of part, you expect a kind of process during 1 year, 1 year and a half, 2 years, less than what that?
We have actually done similar projects within 1 year.
1 year?
Yeah.
Okay, thank you very much. Is there any other question from the audience? Okay, yes?
Check. All right. I have a question for Timo. We're familiar with the RDM space. It's a fantastic space. So awesome to hear you guys are working in there, and great presentation. For the propeller that you produced, what was the division of cost between the 3D printing and the post-machining, post-processing?
Well, the post-processing in this case took quite a lot. the first prototype that we made, one of the partners that we made the propeller with was Autodesk, and they have their whole facility in England where we mill down the blade automatically with a CNC machine. However, all propellers that are made by the supplier ProMarin, which is also part of this this group, they are ground down by hand after they are casted. And so that's what we also did with 3D printed propeller. So we printed the propeller a lot thicker than it should be, because we didn't know yet how the material would deform after the welding, and how the material would behave, and it will be heat treated after, so it's glowing, and then cool down, so it deforms a bit. So then it was ground down by hand, and I think this took one guy about 2 weeks working a lot more than full time, just to be sure that it would be exactly what we needed. It was 3D scanned quite often, and then you can see where it's a bit too thick still. So in that case, it was a bit more. If we want to do it again, we've now learned how the material behaves. Of course, we will do it by CNC milling, maybe then finish it by hand, so it can be faster.
So quite similar in terms of the actual casting process anyway. It needs to go through the same stages.
Yeah, it was really the first, and not, as I said, we will not be printing propellers in series yet.
Cool, thank you.
Okay. And one last question for Víctor from Navantia. Please, Víctor, can you explain us, or can you make some vision, or your vision about how many parts, or if the parts will increase in the parts you are envisaging to be printed in your vessels, in your ships, are increasing, moving from metals to polymers, or just only in polymers is big enough, big area enough to increase, to improve your
no,
adoption?
we want to change all the parts we can in the vessel for polymer pieces, because we have the problem of the maintenance. The maintenance is very important in a vessel. And then, for example, all the pieces above the main deck are not class pieces. Then it's not necessary certificate. Okay? Then we can change all these pieces. Why not until now not change these pieces? I think because this industry is very traditional. No more. No more. Now we have the additive manufacturing, and now we have this technology, and now we can change these pieces. And yes, in the future we want to use that technology, one technology, metal technology, but only for special pieces with great value. Okay?
Thank you very much. If it's not any other question, I really would grateful. I am grateful for your participation. I thank you for your contribution, and hope you enjoy your stay in Barcelona. We are here to help in what you can. I mean, we can. Sorry. Thank you very much.